Did you know the Earth is literally shaking because of melting ice? It sounds like something out of a sci-fi movie, but it's a terrifying reality. We're talking about massive glaciers shrinking at an alarming rate, and in doing so, triggering earthquakes. How can something as seemingly stable as a glacier cause the ground to tremble? Glaciers, those immense rivers of ice that have slowly shaped the land for millions of years, are now changing in ways that impact the very foundation of our planet. The rapid retreat of glaciers due to rising temperatures is not just a story of disappearing ice. It is a story of shifting geological forces and, unexpectedly, seismic activity. In this video, we all explore how something as seemingly inert as the loss of ice from glaciers can set off a chain reaction that results in earthquakes. From the science of ice-quakes to the tectonic processes at play, we're about to reveal the fascinating and sometimes alarming connection between the retreat of glaciers and seismic events. Imagine standing on the edge of a massive glacier, its surface cracking and groaning, releasing chunks of ice that crash into the ocean with thunderous force. What you are witnessing is a phenomenon known as calving, a process where large sections of a glacier break off and fall into the water, creating waves that ripple through the air. While it may seem like a dramatic event of nature, this calving process is just the beginning of a much deeper and more complex story that connects glaciers to earthquakes. Now consider this. What if the retreating ice, as it melts and moves away, is actually causing tremors in the ground beneath us? It sounds almost impossible. Ice is solid and stable, so how could it trigger earthquakes? The truth is that glaciers, while they may seem immovable and quiet, are part of a much more dynamic and unpredictable system than we realize. What we're about to uncover is the scientific mystery behind this phenomenon. How can the retreat of glaciers lead to seismic activity? How does something as seemingly passive as the slow disappearance of ice cause the ground to tremble? Let us dive into the science of ice-quakes and the connection between glacier retreat and the shaking of Earth's surface. Before we can fully grasp how glaciers can trigger earthquakes, we need to understand how glaciers work in the first place. A glacier is essentially a massive, slow-moving river of ice, formed over centuries from layers of snow that accumulate and compress. As the glacier moves, it carves through landscapes, shaping valleys, mountains, and other features. This movement is extremely slow, but it's powerful and persistent. In the past, glaciers would advance and retreat in response to natural climatic shifts. During ice ages, glaciers expanded, covering much of the Earth's surface. When the climate warmed, glaciers would retreat, but the process was gradual and did not disrupt the planet's geological stability. However, in recent times, the warming of the Earth's atmosphere has caused glaciers to retreat at an unprecedented rate. This rapid melting is not only accelerating the loss of ice, but is also changing the underlying processes that govern the movement of glaciers. As glaciers retreat faster than before, the pressure they exert on the Earth's crust is reduced, which sets the stage for seismic activity. Now that we have a basic understanding of how glaciers work, we can begin to explore how their retreat is linked to earthquakes. When a glacier moves, it exerts immense pressure on the underlying bedrock. This pressure forces the ground beneath it to deform, causing the Earth's crust to bend and shift. But when the glacier begins to retreat, that pressure is released. This sudden shift in the weight distribution can cause the ground to move in response. Think of it like a pressure cooker. When the pressure is suddenly released, the system can react in an unpredictable way. The same thing happens when glaciers retreat. The release of pressure causes the ground to shift, sometimes in the form of an earthquake. In areas where glaciers have been retreating rapidly, seismic activity has increased, with scientists observing a noticeable uptick in tremors and minor earthquakes. These events, while not as destructive as major earthquakes, are a clear sign that the retreat of ice is influencing the Earth's geology in a significant way. In essence, as glaciers melt and shrink, they are triggering a release of stress within the Earth's crust. This process, which can cause small tremors and even large quakes, is one of the most surprising and unexpected consequences of climate change. One of the most direct forms of seismic activity linked to glaciers is known as an ice-quake. These are tremors caused by the sudden movements of glaciers as they melt and retreat. An ice-quake can occur when a glacier shifts rapidly or when a section of the glacier breaks off in a calving event. These quakes are typically localized and are often mistaken for small earthquakes. An ice-quake happens when the ice, under stress from the melting process, fractures or moves quickly. This can cause the surrounding rocks and sediment to shift, generating seismic waves. In some cases, ice-quakes can even trigger more significant seismic events, particularly in areas where glaciers are large and the retreat is rapid. Scientists have been closely monitoring ice-quakes in polar regions, especially in areas like Greenland and Antarctica, where glacier loss is happening at an alarming rate. These tremors are providing valuable insights into the relationship between glacier movement and the underlying geological activity. By studying these tremors, researchers are gaining a better understanding of how the planet's crust responds to the loss of glacial ice and how it could influence future seismic events. To fully understand the connection between glaciers and earthquakes, it's essential to address the underlying driver, climate change. Over the past century, human activities have contributed to a dramatic increase in global temperatures, leading to the accelerated retreat of glaciers worldwide. In the past, glaciers moved at a much slower pace in response to gradual changes in climate. However, the rapid pace of warming in the last few decades has caused glaciers to melt at a rate that is much faster than nature's typical cycles. This accelerated melting is causing glaciers to shrink in ways that have never been observed before, and the effects are felt not only in the polar regions but around the globe. As glaciers retreat, they release massive amounts of fresh water into the oceans, contributing to rising sea levels. But the geological consequences are equally significant. The loss of ice, combined with the increased movement of glaciers, is triggering seismic events that can have far-reaching implications for both local and global environments. The melting of glaciers is one of the most visible signs of climate change, and it is also one of the most profound in terms of its impact on Earth's geological processes. As the Earth's icy giants shrink, they are shaking the very ground beneath us. There are certain areas where the retreat of glaciers has had the most noticeable impact on seismic activity. These hotspots are located primarily in regions with large, rapidly retreating glaciers, such as Greenland, Alaska, and parts of Antarctica. In Greenland, glaciers have been retreating at an alarming rate, with the Greenland ice sheet losing mass every year due to both melting and calving. As the ice retreats, the land beneath is rising, a process known as isostatic rebound or glacial isostatic adjustment. This rebound occurs when the weight of the glacier is lifted and the land begins to move upward, triggering earthquakes in the process. In Alaska, glaciers like the Columbia Glacier have been retreating rapidly, and seismic activity has increased in line with the glacier's movement. Similarly, in Antarctica, the West Antarctic ice sheet, which has been losing ice at an accelerating pace, is linked to an increase in ice-quakes and other seismic events. These hotspots are being closely monitored by seismologists who are studying how the rapid melting of glaciers is influencing seismic activity in these regions. The relationship between ice loss and seismicity is a critical piece of the puzzle when it comes to understanding the full impact of climate change on our planet's geology. The future implications of glacier retreat and its connection to earthquakes are still not fully understood, but it's clear that the acceleration of this process could have significant consequences. If glaciers continue to shrink at their current rate, we can expect more frequent seismic events, particularly in regions where glaciers are large and rapidly retreating. The increase in seismic activity could also have secondary effects, including the destabilization of ice shelves, which could further contribute to sea level rise. The interaction between glaciers, seismic activity, and the overall climate system is a complex one, but one that is becoming increasingly important as we continue to face the challenges of climate change. What can we do to mitigate this effect? While there is no simple solution, it's clear that reducing greenhouse gas emissions is the most effective way to slow the retreat of glaciers and reduce the overall impact of climate change. By curbing global warming, we can reduce the speed at which glaciers are melting and prevent some of the seismic activity associated with their retreat. In addition, improving our understanding of glacier dynamics and the connection between ice loss and seismicity will help us better predict future events and their potential consequences. The retreat of glaciers is not just a story of vanishing ice. It is a story of how the very ground beneath our feet is being shaken. As glaciers melt, they trigger seismic activity, setting off a chain reaction that could have profound impacts on Earth's geology and climate. The unexpected connection between climate change, glacier retreat, and earthquakes is a stark reminder of the delicate balance between our planet systems. As the ice melts and the ground shakes, the message is clear. Earth's systems are interconnected in ways we are still trying to understand. The loss of ice from glaciers is one of the most visible signs of climate change, and its impact on seismic activity may be more significant than we realize. As we continue to study this phenomenon, we must remember that the shrinking of Earth's icy giants is not just a visual change, it's shaking the very foundation of our planet.